So hey guys, today let us solve different problems on the combinations of resistors. But before doing that, let me do a small recap on resistors in series as well as in parallel. So for resistors in series, we know that the current through each resistor is same and the sum of the potential difference across each of these resistors R1, R2 and R3 is equal to the potential difference applied by the source. And the equivalent resistance is which is given by R equivalent is equal to R1 plus R2 plus R3. Now for resistors in parallel, the potential difference across each of these resistors is same and the sum of the electric currents flowing through R1, R2 and R3 is equal to the electric current which is drawn from the source. And the equivalent resistance for resistors in parallel is given by 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now let us solve few questions. Now coming to the first question, okay, the answer is already come, but still let's solve this. The first question is, a piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then the ratio of R by R dash is. Okay, now let us assume that this is a wire of resistance R which is cut into 5 equivalent parts, okay. So each of the 5 parts will be having a resistance, an individual resistance of R by 5, okay, because they are cut from the original wire resistance R. That's why they will have R by 5 resistance, and all of them are connected in parallel, okay. All these 5 are connected in parallel and that combination is R dash. So it is like writing 1 by R dash, okay. Just to find the equivalent resistance, 1 by R dash is equal to 1 by R by 5, okay. 1 by R by 5 plus 1 by R by 5. We need to write them 5 times for each of the 5 pieces. Okay, 1 by R by 5, again 1 by R by 5, that's it. And solving this, we will get R dash is equal to R by 25, okay. Okay. Now on finding the ratio of R by R dash, which can be written as R by 25, we will get 25 ohm, okay. And that is the answer, you can verify it here. Now moving on to the next question. Okay, wait. Yes. Now the second question is, two resistors of resistances R1 is equal to 400 plus or minus 3 ohm and R2 is equal to 300 plus or minus 4 ohm are connected in series. The equivalent resistance of the series combination is. Okay, so this plus or minus is nothing but the error, okay, error correction for this, but we don't have to worry about that. Then we are adding the resistances in series, okay, we simply add them, all of them, okay. So the resistances in series, it is nothing but R1 plus R2 will give us, okay, so we are adding 400 and 300 which will give us 700, okay, 700 plus or minus, we are also writing that, we are adding this 3 and 4 plus or minus 7 ohm. That's the answer, okay. Now let us check this, 700 plus or minus 7 ohm, yes. Now moving on, the third question is, the equivalent resistance between the point A and B in the circuit shown is. Okay. Now, on keen observation, we find that the potential across each of these resistors is same. Okay. Now, see, this wire connects this 2R as well as this 2R, okay, parallelly, and this 2R is connected to this R again in parallel. So now we are simply going to add all of them in parallel combination. So 1 by Rp is equal to 1 by 2R plus 1 by 2R plus 1 by R, okay. And on solving we will get R by 2 as the answer, okay. R by 2 ohm will be the answer. Now the fourth question. The wire used in the arrangement shown in the figure has a resistance of R ohm per meter. The equivalent resistance between A and B is, okay, the equivalent resistance between A and B. This might look a little trickier, but still let us try to solve this. Now we are having a minor arc over here, okay, minor arc here, a right angle triangle here, and a major arc here. Only on adding each of their individual resistances, we can find the equivalent resistance between the point A and B, okay. So, to find the length of an arc, the formula is S is equal to 2 pi R times theta by 360, okay. This is how we find the length of an arc. When theta is in degrees, we know that theta is in degrees because it is in a right angle triangle here. So we simply take theta as 90, okay. Now, writing the length of a minor arc, okay. Minor arc, the R value will be 1, alright, and theta is 90 degree. So we can write it as S1 will be pi by 2 meter, alright. Now writing the resistance of this minor arc, it will be resistance of minor arc, we'll just write it as R1, alright. R1 will be pi by 2 small r ohm. Yes, don't forget the small r here. Yes, pi by 2 r ohm. And now writing the resistance for the wire, okay. Now here it is 1 meter as well as 1 meter here. 1 meter is the length of the radii. So now let us write for the wires. We'll write them as R2. Now simply adding this 1 meter and 1 meter here, we'll get 2 meter. So the resistance for the wire will be 2R ohm, alright, 2R ohm. And now the resistance for the major arc, which will be given by simply using this formula again, okay, 2 pi R times theta by 360. Now for theta, we are going to take it as 360 minus theta in the numerator, because the angle for the major arc will be this angle now. So on taking 360 minus 90, we will get 270, okay. So on substituting the values in this formula, we will get R3 as 3 pi by 2 R, alright. 3 pi by 2 R ohm. Now we have got the resistance for each of these individual components. Let us simply add them now. Whether it will be in series and parallel, it will be in parallel, okay, because we have to find the equivalent resistance between A and B. And if you simply check the diagram, all the components are in parallel, okay. So on writing all of them in parallel, we'll get the answer as 6 pi r by 16 plus 3 ohm. That's it. Now coming to the fifth and the last question. A wire of resistance 10 ohm is bent in the form of a closed circle. What is the effective resistance between the 2 points at the ends of any diameter of the circle? Okay. So this is the circle of resistance 10 ohm. Now if we are taking the diameter across any 2 points, okay. Now let this be the diameter. Okay. The diameter AB. Alright. So we should know that a diameter can cut the resistance in 2 equal halves. Alright. Now the total resistance is 10 ohm. So each of the resistances of these two, only of these two halves will be 5 and a 5. Okay. 5 ohm and 5 ohm. And they both are in parallel as well. Okay. So we simply write 1 by Rp is equal to 1 by 5 plus 1 by 5, 1 by 5 plus 1 by 5. Okay. So on finding Rp, this way we'll get it as 2.5. I hope you understood. Thank you.